Tonight I'm going to be talking about current limiting resistors for LEDs. So if you're new to the world of electronics, you might have noticed that every circuit that uses an LED uses a resistor in series with the LED. And the reason why we do that is because LEDs are rated to a particular current, and if you exceed that current they're just going to burn up. So in this video I want to go through how we would select the value for the current limiting resistor. There are two important pieces of information that you need to know about your LED. The first is the forward voltage, which is the voltage drop of the diode, and the second is the forward current. You can get most of this information from the data sheet. What we have here is a fairly standard red 5mm LED, and we're going to look on the supplier's website, and you can see here that the forward voltage is listed at 2 volts and the forward current is rated at 10 milliamps. You may not always be lucky enough to have the data sheet for your LED, so if you don't, for most modern 5mm LEDs you can assume a forward voltage of between 1.8 to 2.2 volts if it's red or green, or if it's blue or white it will be a bit higher, about 3.6. You can also assume that most modern 5mm LEDs will have a forward current of between 10 to 20 milliamps. So for our 5mm red LED we're going to choose a forward current of 10 milliamps and a forward voltage of 1.8 volts. So in order to get a resistor value we have to do some maths. If you're scared of a little bit of maths then don't be, because this is actually very simple and it's just Ohm's Law. So here's the calculation. R, which is our resistor value, equals V, which is the voltage across the resistor, over I, which is the current flowing through the resistor. So we just need to plug some numbers into this calculation now. V is going to be our supply voltage, so let's say in this case that that's 5 volts, minus the voltage drop of the LED, which is 1.8 volts, which gives us 3.2 volts. Divide that by the desired current. Now this is in amps, so it's actually going to be 0.01 amps or 10 milliamps. So that gives us R equals 3.2 over 0.01 equals 320 ohms. Very simple. So because we don't have a 320 ohm resistor, instead we're going to use the next value up, which is 330 ohms. Let's go ahead and wire this circuit up. So we've got our red LED and we've got our 330 ohm resistor, and we've also got an Arduino which we're using as a convenient source of power. So I've wired our black jumper wire to our ground connection on negative, and I've wired our white jumper wire to the power or 5 volt terminal. I'm going to get our LED, and as you can see, this, I don't know if you can see that has 2 legs. There's a long leg and a short leg. So the long leg is the positive side of the LED. You can also identify the negative side by looking for the flat edge of the LED. So we're going to go right ahead and we're going to connect our negative side to the black jumper wire, and I'm going to connect our positive side through the resistor to the white jumper wire. As you can see, our LED lights up. So I'd just like to talk a little bit about what if we want to connect multiple LEDs. First of all, I'm going to show you the wrong way to do it. This seems like the most obvious way to do it, but it's not. Because the two LEDs only have one resistor between them, one of them is always going to take more current than the other, because not all LEDs are created equally. The correct way to do this is actually to give each LED its own resistor. So we're going to go ahead and draw another diagram. And we have each LED and resistor in parallel, like this. This means that each LED will only draw the current that it needs to. I hope this has been informative. If you have any questions or comments, I'd love to hear from you in the comment section. I'm going to be doing a couple of new videos each week on basic electronics subjects, so keep watching and please subscribe. Thank you.